So in homework 2, we had asked you to design a 5T current reference based on the design that I had presented in lecture 2. This current reference, the key spec that we wanted to achieve here is we want it to be extremely low power, less than 10 picowatts of power consumption. It should, as a result, output a pretty low current as well, a picoamp, which could obviously then be increased through a current mirror multiplier to bias, an amplifier or whatever it is that we're using here. And most importantly, it needs to work with an unregulated supply voltage, 0.5 volts to 1.8 volts, with an output current supply sensitivity of less than 1% per volt. Now, normally we'd also ask to have it temperature stabilized and robust against process variation and so on. It's a little difficult for us to do that within the confines of the LT Spice simulator that we're using here. And so we only, we're talking about the output current sensitivity. We said, you can use these two different transistors, and then for simplicity, you can use ideal resistors and capacitors. Again, this is not a complete PDK with full cadence integration and so on. This is just kind of a way to get your feet wet, as it were, to try and start to design some of these things. So some of the design hints we said is, start without the regulation transistor. Ultimately, this regulation transistor doesn't affect things too much, but it's kind of nice to start without it, and then things are just a little bit more idealized here. Another hint was, we're going to obviously be in subthreshold here. These currents are extraordinarily small, and just make sure all of your transistors are saturated as you normally need for good analog design. In this case, that just requires VDS to be larger than 100 millivolts. And then what you'll find is that the size of these transistors are going to be a little bit larger than you're used to using, lengths of 5 and 40 micron and stuff like this for some of these transistors end up meeting the specs. So here is the design with the widths and lengths annotated that we ended up coming up with. Here's the operating points showing that all of the transistors are indeed operating in the saturation regime. The total current consumption of this design was a little bit under 10 picoamps, 10 picoamps. When you sweep VDD, what you'll find is that output current varies by a little bit less than 1% per volt. So in this case, it was 0.22% per volt, which is a pretty good result, right? There's a lot of applications for IoT and so on that rely on energy harvesting or that use batteries that have deep discharge cycles, and having the ability to generate a stable current source across a wide supply voltage range is very important in those kind of applications. Especially this one basically consumes almost no power. I mean, the power consumption here at nominal supply voltage is 5 picowatts, right? So this is almost nothing. So anyways, you're welcome to take a look at this design, play around with it, and see what you can get there. Okay. How do you mirror out the reference current out of here? So that was a question on the chat. So you have so your current is passing through this branch here. So what you can do is the current is passing through this M3 transistor. So you can just take the current here and mirror it out using the same VGS, perhaps using the same regulation transistor. Or the current being dropped across this known resistance, and so this has a Ohm's law defined VGS or Ohm's law defined voltage drop, so you could use that to bias a transistor. There's a number of different ways you could do this.